Hello everyone and welcome back to the channel. This is my first video in 2022, so happy new year to everyone, and I hope you guys are having a great start to this new year. So in this video I'm going to continue with the shaders material topic in Three.js, and I'm going to show you how we can create an effect like this. So far we have learned how fragment and vertex shaders work, and we have also been able to pass variables from our JavaScript file to our GLSL files. And this here we're gonna work on animating every single vertex of this object. If you haven't seen my previous videos, I strongly recommend you go and check them out. I'll put a link to all those videos throughout this video on this top right corner, and also as always you can go to the channel homepage and look for different videos, and I've also created a playlist for Three.js. You can check that out as well. One quick note before we get started: if you are new to this channel, make sure to hit the subscribe button below and turn the notification on so you are the first to know when I publish a video. Alrighty, as always we're gonna get the starter code from GitHub. I'll post this GitHub repo, the link to this GitHub repo, to the description box of this video, and you will see I will have eventually two branches here. The starter branch is the code if you want to code along with me and start from where I start, and there will be also a final branch where it will be the final code of this video. So go ahead and click on this code button here, and you can download the zip file or clone it, and then you should be able to unzip and open your folder in your IDE of choice. I'm using VS Code here. First thing you need to do is to do npm install in your terminal. I've already done that, and then you can get your node modules folder, all the packages installed, and then once you've done that you can run the dev server using npm start. These files and folders here, I keep mentioning this in all my videos. You can go ahead and check my very first video where I explain to you how I've set up my Webpack boilerplate, and this is actually a production ready boilerplate that you can use. I'll put a link to that video also up here on the top right corner. Okay, so now our terminal is running, dev server is running, so we go to localhost 3000, and let's check out what we have. We're not gonna really care about the other pages except for the Three.js page, so you can navigate there, and we have just a simple sphere geometry here that we previously, in like maybe 2 or 3 videos before this one, I showed you how you can use fragment shaders to basically mix two colors and have this kind of coloring on your object. So again, if you haven't seen that video, make sure go and check it out. In this video, as I mentioned, we are gonna do some mouse hover effects. When you hover your mouse on top of this object, we'll see some kind of like animation happening on each vertex of this sphere geometry. So to do that, in one of my previous videos we have already added mouse down and mouse up events. Again, go check those out, but we're gonna do the same thing here, except this time we are going to add a mouse move event, and that's we're gonna add that to our add event listeners, And by the way, I should have mentioned that I'm currently in my index.js file directly under the app folder. The app folder is where we do all our front-end JavaScript. So this is our entry point there, and that's where I am right now. We have this add event listeners in our constructor, and we've been adding all our event listeners here so far. And same thing we're gonna do with the mouse move event, and then this is not Threejs, this is just like the JavaScript event listener part, and we need to define this on mouse move function also. So I'll add that here. Again, like I said, similar to mouse down and mouse up, we're gonna see if our canvas has that function, and then we'll call that function in our canvas. And by that, what I mean is that we have this canvas here. Canvas is where we have all our Threejs related stuff. There is an entry index.js file. I'm gonna save this here. And with this line here, we are basically sending our mouse move event to the index.js file right under canvas folder, and there we can receive that function, and we can do that similar to mouse down and up that we did. And then from there, this is our entry point to all our Threejs files, right? Folders, well, but technically are our Threejs pages, but since we have only one right now, we will be adding this on mouse move to our Threejs file also, which is the index.js under Threejs here. So again, this is all JavaScript side, and I've talked about all these things in detail, so make sure go ahead check out my previous videos. I'll also put a link up here for each relevant video when I talk about them. And finally, we are going to call this onMouseMove function in our index.js file under Threejs folder. This is where we are doing all the Threejs stuff related to our Threejs page. So right now we do see this error because we haven't defined the mouse move in this page. So to do that, I will just basically bring on this mouse move here. This Threejs index.js file is very similar to what we had a couple videos ago. I've just cleaned it up, and we also had a plain geometry. I removed that, and in the previous video or one before, I explained like we added this shader material to our sphere geometry here. If I save it right now, we should that error should also go away. And here you can see that like we have this object with different colors there. We'll look into the fragment and vertex shader files soon. Okay, so the next thing we're gonna do here is we're gonna detect our mouse cursor movement in the page, and see if it actually, when it hovers over the object, we're gonna just console.log something. So inside our mouse move function, we're gonna we have already defined our raycaster and our mouse here. I've talked about this in another video also, so make sure go check that out. All this code we have used it in the other videos, and so basically I'm just trying to follow the cursor, and then using raycaster method in Threejs, I will be trying to see where it intersects with an object, and once I do that, the next thing we should do is to see if this intersects length is more than 0, and if it is, I'm just gonna cancel that like that. We are actually hovering on our object. Again, this code, everything here, I've explained it in previous videos, so make sure to go check that out if you don't know what I'm talking about. I'm gonna save this file right now, and if we go back to our Three.js endpoint here, right now moving, if I hover, you can see that this number is increasing. As soon as my mouse moves over this object, you can see that we are actually detecting hover event there. So that's good. We took care of that. The next thing we're gonna do is actually go up here in our shader material. We have these two colors that we are defining in our fragment shader. Right now we are defining both colors, like a white and a blue color, inside our fragment file, but just to show you another way that you can do it, you can actually send these files through uniforms in your shader material, and then receive that in your fragment shader here. So what I'm gonna do, I'm gonna just comment out color 1 and color 2 and our mixed color vector 3 here, and then here I have I'm sending two colors, uColor1 and uColor1 as two uniform to my fragment file. And this is how you do it. Go check out the other videos if you don't know what this is. So I'm gonna save this, and then here I'm gonna receive that fragment, those two colors, uColor and uColor1, and don't forget to define the type. Both of them are going to be vec3s as we had here for our color 1 and color 2. And the next thing I'm going to do, we just have to create that mixed color using these two, uColor and uColor1. And so these two colors are not blue and white anymore. They're like some different colors. It's up to you, whatever color you wanna pick, you can do that. I'm just trying to show you that you can actually make it like variable or things like that in JavaScript, do some stuff on that, and then send that to your fragment GLSL file through uniforms. And as you can see, we have like those two colors, and they're kind of blending in each other, kind of like mixing together. Okay, so that's that. And now the next thing I'm gonna do is to add a time variable to my vertex GLSL file. And we've also talked about in the previous video. So you can define, basically you can get the elapsed time from when the page is loaded using the Threejs Clock function or method, and then once you basically store that 3 clock in your clock property here, you can then later on in your update function, you will be able to get the elapsed time from basically when it's loaded, when the clock started, which was the page load, and then you can assign that to your u time for your material. And again, this is what we've seen before, the value of u time of uniforms in your material. And that's exactly u time, value of u time in uniforms of your material. That's how you can assign that, assign elapsed time to that value. So I'm gonna save this. At this point, nothing is gonna change in here, because we are not actually receiving that U time in our vertex or fragment shader. So you can still see that we see the hover event happening there. If I go to vertex GLSL file here, and I basically receive this uniform U time variable, I can use that in my position instead of my position value here. And since we can't manipulate this position value or attribute here, we have to actually store it in another variable. And to do that, we're gonna define a new vec3, because position is a vec3, and we have to define a new vec3 variable. And now we can actually manipulate this new position. And like before, you are gonna end up using a lot of trigonometry functions, and including sine, cosine, especially sine and cosine. And then you can assign different x, y, and z positions based on the u time, but you would want to have like a sine or cosine of that, because this u time keeps increasing, and if you don't basically control that, it's just gonna go up and up. With sine and cosine, you make sure that it stays between -1 and +1. This is like math stuff, so if you're good at math, you can like play with this. You can combine or mix sine and cosine and all those things. We'll see a couple things that we will be doing in this video. And after you do this, don't forget to change your position here to new pose, because that's what we will be using to just define our position, the position of the vertices. So if I save it right now, we are sending the elapsed time from the load through this uniform to our vertex shader, and then assigning that basically u time using some trigonometry functions to the position attribute, which we have saved under new pose variable here. So I've saved it, and if I go here, right now we are not doing any hover effect. We still do capture the hover, you can see here, but the u time is gonna increase as soon as our page is loaded. And with this all sine functions, only the u time with sine functions, this is what you're gonna get. Basically your entire sphere is gonna bounce front and back, and that's what these sine functions do. You can read more if you want to dig deeper and see why this is happening. Just try adding I don't know, maybe you can make an Excel sheet and add different times and then calculate x, y, z, and then see how that function looks like in there. But that's out of the scope of this video. All I'm trying to show you is how you can get what you need, and basically then you will decide how to use that. So we have u-time here. Let's go back to our Threejs file, the index.js here. Now what we're gonna do, we are going to add we are going to add some random variables to our vertices here in our geometry, and then we'll animate those variables, and you'll see for each vertex you will have different kind of a random variable assigned to that. So like here you can see what's happening here is that imagine every single like vertex on the sphere, and you can see like each of them are being animated differently, like the range of their extension and all that is kind of like different. Here you have them facing out, obviously all of them are facing out, and things like that. So we're doing animation on every single vertex here, and that's what we're gonna do next. If I console out like this geometry, we will see that we're trying to see first of all how many vertices do we have, because then we're gonna assign some kind of attribute to each vertex. And if we go to our attributes under geometry attributes position, you can see this count variable here, and that's the number of vertices that we have, 2600 or 2601. And then we're gonna get that variable here. Let's see, I'm gonna comment out geometry, and that number, that count was geometry attributes position and then count, geometry dot attributes dot position dot count. So that's gonna give us the count, which is 2601. And next thing I'm gonna do, I am going to define a float 32 array and store it in my in a randoms constant. Why do we define this kind of constant? I'll let you know a little bit later in a minute, but for now we want to have a float 32 array. It's basically a kind of array that you will it will have 2601 random numbers in it. And I can actually show you what float 32 array is. It's a typed array. I'll share this link with you guys, you can read more. Represents an array of 32-bit floating point numbers. I'll let you know why we are using this here, but this is some kind of array that will include 2601 random elements, and that's the number of vertices that our geometry has. And then inside that randoms, it's an array, so we're gonna just assign just random numbers between 0 to 1 to each basically each element of that array. And I can console.log it so you guys can see it. It's just some JavaScript and array function stuff, nothing related to Threejs so far. You can see I have 2601 elements in my float 32 array, and if you look at like the numbers, everything is gonna be like a math.random number, which is between 0 to 1. Okay, now why did we define that float 32 array? Because we wanted to define an attribute for our geometry that will include all these random numbers, and then later on we want to pass that to our vertex shader, and then based on the random numbers for each vertex, we will kind of like animate that specific vertex. So here inside the index.js file, the way we define a new attribute for our geometry is using the set attribute method. And you can go to the Threejs website, and you can search for set attribute, and as it says, sets an attribute to the geometry. we need a name, which is going to be string, and attribute of buffer attribute. So we're assigning a name, we call it random, just it's a random number, and we add like a here since it's an attribute. So far we've had uniforms, and also we used in previous videos varying. If you don't remember, go check those videos out. Basically uniforms, and I have comments for both of them. Uniform type is used for the data that don't change among the vertices, and varying type is used to make a variable available in both vertex and fragment. Basically you can send it from your fragment from your vertex to fragment shader file. You use varying for that. But the third type is attribute, and attribute is a type of data that does change among the vertices. So that's the difference between uniform and attribute, and this a random is going to change to be different among the different vertices. So that's why we are setting it as an attribute. We are not sending it as a uniform here. And then the second part, as we just saw, is a buffer attribute. And if we look at what buffer attribute is, again, I will put the links to these Threejs document pages. What we need there is a typed array and an item size at the minimum. If we look at float32 definition, it's a typed array, so that's why we used for float32 array, because this is a typed array. We are having an array of float32 numbers. So like all these guys, math random, it's a number between 0 to 1, and that's a float number, since we will be receiving a also float number here as that random number in our vertex file. That's why we use that float32 array here. And you can also look there, the item size is the number of values of the array that should be associated with a particular vertex. So for each vertex we just want one of these numbers. So for example, if you were having you were defining an attribute which was a vec3, then you would say 3 here, because 3 of those random variables would be assigned to one vertex. But right now we are just having one float here. This float is just one single number, and each single number is gonna be assigned to one vertex. That's why we made sure that this count number, which is the number of vertices, we also get random numbers and the same number of random numbers. So both of them are 2601. Alrighty, so now we have our random variables attribute here, and you can save it. The way you receive a random attribute in your vertex file is to just similar to uniform or varying, you'll define attribute and then the type, which is float. Again, we had those float32 arrays, and then we don't need to pass this through our shader material. We are already setting that attribute to our geometry, so that's part of our geometry. It's technically not like part of our material. And so we have added that, and then the next thing we're gonna do, we're gonna use this a random in our position functions down here. And simply we can just multiply all these sin u time by that a random. Again, this is just what I'm doing here. You guys might want to like multiply by, I don't know, 2 and then a random, or like all you should do is to like save and then see how it looks like and try to make sense of that, and then make changes accordingly to get to where you want to be. So right now you can see that this thing is just like increasing in size, and then just like you can see every single vertex is actually moving uh, according to like that random attribute that we had. And the reason it's like moving is again the u time, because for each vertex we have a single random variable. Okay, now we're gonna make it a little bit more interesting, because the main goal was to have this animation happen on hover, but that's not happening. It's like happening all the time right now. So in our index.js file under Threejs, we are going to add to another uniform under our material. We're gonna call it uHover state, which will include the hover state. If we are hovering, it's gonna be 1. If we're not, it's gonna be 0, and it's set to 0 by default. And then in our onMouse move function, if we detect that intersect, we want to increase that value to 1. And similar to what we did here for u time, we're gonna use gsap here to gradually change that 0 to 1. And again, we will use we want to change the value of uHover state in our uniforms in the material, as we discussed down here. Same thing is happening here. And I'm using the expo in out is you can go to Greenstock website, you look at their ease visualizer, and this one here, expo in out, is kind of like slow and suddenly really fast and then slow again. You'll see that in the animation. If I save it now, I still need to receive that uniform in my vertex file, so it's also a float. And then we can basically multiply all these positions by uHover state, since it's either 0 or 1. If it's 0, all of them are gonna be 0, so nothing will be happening. Keep in mind that we are adding here the sign values to our new position. We're not saying it's equal to that, we're adding it, so it's gonna be keeping adding that. And if we have a uHover of 0 multiplied by this, then we won't be adding anything to our position, so it's gonna be as it is, just like as a complete sphere. And we can see that if we go back to localhost 3000 here, it's loading now. So once we load the page, nothing is happening again, because that uHover is 0, so we're not adding anything to our XYZ position. As soon as I hover over, it starts, and you can see that animation happening. But right now we haven't set anything for when we hover out, so let's go and fix that. If we have the intersect there, we'll animate it to 1, and if it's not, there is no intersect, if we are not hovering over the object, we'll just animate it to 0. And save again, and I'll show you just how that expo in out animation, you can see that here. It's gonna be slow at the beginning and then real fast. See that? Like, and the same when we hover out. Slow, real quick, it's gonna be fast, and then slow. And so that's like the animation that we have now. It's working with hover state. And if we look at my portfolio website, I have some kind of similar effect there. Obviously it's not exactly the same, but And that's also something you can achieve using the same methodology that I just explained to you. Let's see, is there anything else? Actually, we can make that circle like rotate from the beginning. So if you again we look at my website, you can see that this circle is rotating around the y-axis. But like in our update function, we can rotate our object here, like I'm doing around x and y axis. And if we go back, you can see that's gonna happen without hover because it's in our update function, and it keeps it's gonna just keep adding 0.01 there. You can clearly see that here. You see like the kind of like bluish color, and then the green. And then if I like do this, you can actually more clearly see that here. And then let's see, for the vertex file, we can also change it actually as a y and z to cosine, just to see how it looks like. I found that like x sine and y z cosine most of the time looks better than like if you use just sine for all of them. Again, this is all up to you. Just play with these functions, and or like search online. I'm sure there are some cool functions that you can find. So like this one here, this seems also kind of like cool, but it all depends on you what you want. This kind of effect, I guess, is good, kind of like you want to have some kind of wave stuff, or I don't know, I've seen like the music player app, you can have this also, kind of like what I have here. That's like music playing, and then this is not playing, or like some kind of like fire kind of like effect there. But anyways, that's I think all I had for today. Just make sure you go play with this sine cosine. Try to add like in more different type of functions here. You can also combine them. You can actually define your y or z values based on your x. So you can like do cosine u time multiply by this and multiply by that plus like new pose dot x. So just play with those numbers. Definitely do some Google search, and you can find also some cool inspiration there. So yeah, that's about it. If you found this video helpful, please make sure to like the video, and if you haven't subscribed to the channel, please make sure to do that, and turn the notification bell on so you're the first to know when I publish new videos. This is it for today, and I'll talk to you soon.